continuation of yesterday's lesson. So the first thing I'd like you to do, this would be example 1 here, okay, is just evaluate this integral. So the issue is, how do you integrate that? And once you integrate it, then we're going to sub the limits in. So in looking at this, I can only work it if it's, for this one, if it's a power rule, if it's u to a power. So the first thing, the first approach to take here is I would split this into two fractions first. And then I would change the square root, because we don't have a rule for square root. We have a rule for u to the 1/2. I would change my square root to u to the 1/2. 16 u over u to the 1/2 plus 3 over u to the 1/2. And now that will set us up for two power rules. You can make the first fraction into 1u, and then you can move the second u up. So how do you make that first fraction into 1u, and then move the second, in this problem, move the u to the 1/2 up, and then we can integrate. So the first fraction becomes u to the 1/2, because when you're dividing and the base is the same, you subtract your exponents, 1 minus half, u to the 1/2, and then I'll move this up, but when I move it up, I get a negative exponent. Okay, but now I'm ready, I have two integrals I can do. I'm ready to do power rule. I know that on this one, the 3 will stay with the answer. So now I'll integrate each of these. I'm just gonna start dropping down now so that I can, well, we'll just go here. All right, so the first antiderivative, what's the antiderivative of u to the 1/2? 2u to the 3/2 over 3, so 2/3 u to the 3/2. I'm hoping at this point, right, you've done this enough where you know it's going to be u to the 3/2 over 3/2, and you go ahead and flip like Elijah did. So that's great. Very good. So plus 3 times, all right, u to the negative 1/2. So we're adding 1 and then dividing by that new number. So if you add 1 to negative 1/2, what do you get? 1/2. So it's going to be u to the 1/2, but instead of dividing by 1/2, I can just go ahead and multiply by what? 2. There's that. And then all of this is from 4 to 16. Okay. So we touched on this yesterday. I think we had a 3/2, or the other day, we had a 3/2 power. And I was reminding you how you work that. So the next thing I will do, make this a 6, of course, make this a 2/3. Remember that 1/2 is synonymous with square root, it means the same thing. Okay? So, because I've got to plug these numbers in and get our value. So here, I'll go ahead and plug the 16 in first. So I get 2/3, let me just go this way route so I have room. So I have 2/3 16 to the 3/2 plus, 16 plus 6 times 16 to the 1/2. Okay, so there's where I subbed in my 16. Then I put a minus the quantity of 2/3, 4 to the 3/2 plus 6 times 4 to the 1/2. All right. So now I have to start working these out. So now the problem is now really not about calculus anymore. It's about your 7th grade math or 8th grade math. The dealing, I don't know, when do they give you fractional exponents? Maybe ninth grade math, I don't know. But it's just, now we just have to deal with these square roots and handle getting the value. So how do I do 3/2? What I do is, if it's to the 3/2, I do it to the 1/2 first and then cube it. That means the same thing as to the 3/2. So anytime I have something to the 3/2, if I can take the square root, I'll go ahead and do that. So square root of 16, we get 4. 4 cubed, this becomes 64. So I have 2/3 times 64 plus square root of 16 is 4. 6 times 4 is 24. Minus 2/3 times square root of 4 is 2. 2 cubed is 8. Plus 6 times, or sorry, minus, because this minus has to go to both. Square root of 4 is 2. 6 times 2 is minus 12. This becomes 2. But it's a minus because I have that minus there. All right, and then what I would do is probably combine my 24 and negative 12. So that gives me 12. And then this is 128 over 3 minus 16 over 3. And we get what? 112 over 3. I don't know if that's going to be anything that we can simplify. Make sure my math is right, because early on, when I haven't had my coffee, I'll make mistakes. Everything look okay? 2 times 64 is 128. 2 times 8 is 16, but this is a negative. 128 minus 16, I got 112. So what might be our last step?
You could put them on
the same. Yeah, that's what I would do. Just put them, so combine, so make this 36 and 112, we get 148, right? 148 and over 3. Now, how do I know this is not going to reduce? There's an old divisibility by 3 trick. Do you know this? So if you add the digits, yeah, 1, 4, and 8, that adds up to 13. 13 is not divisible by 3, so this number is not divisible by 3. Let's say you had 126 divided by 3. That is because 1 plus 2 plus 6 is 9. So if the digits add up to a number divisible by 3, then that number is divisible by 3. See, we would get 42 here. Okay. All right, so I know I can stop. So a couple of things. There's 2 parts to this problem that I see. Is you got the part above the line and you got the part below the line. In the part above the line, what did I take most of my time trying to do? Rearrange it. That's exactly right. Rearrange it so that we can do what? That's right. So we needed to get it to here where I can use power rule. So all these first steps is just rearranging it to this point. I need u to a power or x to a power or whatever. Then the rest of that is subbing the numbers in, and then all my work over here is just dealing with that. This part has nothing to do with calculus. I mean, yeah, it does because it's related, but it's not calculus level work. Okay, that's the beauty of this course, is that it takes so many different aspects of things that you've learned in the past in math. All right, so there's that problem. Okay, so why did I pick this one? Because of the rearranging and then the complexity of the problem. Okay. All right, next type of problem. So I'm going to just erase it. We'll leave it there for a second. Of course, you can pause. You have this video, so you can do what you need and go from there. So now let's work another one, and let's try to understand what are the shortcuts I can take and what does absolute value mean. So I picked an absolute value function just because I want you to see what's the thinking we should take when we're working that. So I have the integral from -2 to 2 of the absolute value of x squared minus 4. So we have an absolute value not of a linear function, but of a quadratic. So what I want us to understand, what do these bars mean? What do they do to this function? Okay, and what does that mean for our answer? All right, so let's take a second and just look at x squared minus 4. All right, so if we recall, x squared minus 4 is a parabola that's shifted down 4 units, right? And then, all right, it would be nice to know, where does it cross the x-axis? Can you see? 2 and where else?
Negative.
2 and -2. How do you know that? Yeah. 1 squared minus 4 gives us 0. 2 and -2. That's going to be important always on absolute value problems, and I'll explain why. Okay. So, right now, if I didn't have these bars, if I had this problem, we would be finding what? The area where? Ivan, where would we be finding the area? So right here, if this was the question, where would we be finding the area? What does this mean? What does the -2 mean? Yeah, what's the 2 mean? What's this mean? All right, the graph, and then you go to the x-axis. So, looking there, -2 to 2, where's the graph? Above or below the x-axis from -2 to 2? So you're finding this. So if I work this problem, this is not what I was asking. This is the problem. If I work this problem, how should the answer come out? In terms of positive or negative? Negative. Because the entire region is below the x. So this is the negative of that area. Basically what absolute value is saying, it says, look, we want the actual area. What absolute value means, anytime you see bars, so this is the graph of x squared minus 4. Had I been given this problem and I work it out, I would get this area but negative. What absolute value means, if I just draw it in blue, it takes any negative region, so on top of this graph, I'm going to put the absolute value. Actually, let's just put it next to it, that way we can see. This is what the absolute value of x squared minus 4 looks like. It does this. Any positive parts stay positive. So it's always important to know where your zeros are. What it does is, it says any negative parts are now going to flip and become positive. So you can see that this region here, from -2 to 2, should be the same as this region, except what? Positive. So the question is, well, how do I work this if I have the bars? I'm going to drop the bars because I can't do calculus with the bars. I don't have a rule with absolute value bars. So I'm going to drop the bars, and I'm going to come down here and I'm going to do what to this answer? All right, I don't follow you there. Look, let's go through my discussion again. Let's understand the difference. Right now, what's going to be the difference in the top problem and the bottom problem? What is going to be the difference in the answers? Yes, and one will be what? Negative. Which one can I work right now? The top one or the bottom one? Why can I work the bottom one? That's exactly right. So I'm going to work this problem, and I'm going to know that my answer should come out how? So what do I do to this answer so that I get this answer here? Just take the negative off. Guys, that's all I'm trying to show you. I hope that you're following what here. Let me erase all this. Look, this is your problem. But you're not going to know that. This is what it's asking you to find. But right now I'm trying to get you to understand is what does an absolute value do to a graph? So the first thing you need to understand is, what does it look like without the absolute value? That's why I went to that first. Then I take any negative region and I flip it and I make it positive. But you cannot use calculus with bars here. So the first thing I need to do is drop the bars for now. and look at what that region here looks like. What does this look like? That's why I drew this. So this one looks like this, okay? That's what this looks like. So the difference in the two problems is that one comes out negative, one comes out positive. This is the problem that I gave you. So I'm gonna get the actual area. My answer should be positive. How do I do that? I drop the bars and I find that answer and I know I'm gonna have to negate. So what I usually do is I go ahead and just put a negative. So this answer here is equivalent to the negative of this answer. That's what I was trying to get you to conclude. Okay? Now, here's another shortcut I could do. One more shortcut. What do you notice about, well, this is the problem we're actually doing here. Right? What do you notice from 0 to 2 in regards to negative 2 to 0? They're equivalent. So this half and this half are the same. So what if I only did this half and did what to my answer? Double. I would do that. I would go 0 to 2, but double my answer. Why? Why would I do that? You saw it the other day. What's the benefit of having 0 as a limit? Less computation. When we plug a 0 in, stuff is going to go away. Anytime you can use 0 as a boundary, go ahead. So these are all the tricks. Okay? So essentially, absolute value bars. You take any negative region, flip it, make it positive. Now, how am I going to get the area of that? I've got to negate any of the negative regions. And from negative 2 to 2, it's all negative. Okay? Now you just work it. So let's see. We get negative 2. Antiderivative of x squared is what?
3x cubed over 3.
Minus the antiderivative of 4 is what? 4x. See, now that 0 is going to come in handy. Okay? Now, all I got to do is really plug in a 2. So I can plug in a 0, but it all goes to 0. So I got negative 2 cubed over 3 minus 4 times 2. And then minus, if I plug in a 0, it's all 0, so I just put a 0. So now all you're doing is, you'll see that this answer comes out negative, and then once you multiply by negative 2, it will give you this one, okay? So this should be this area here, net area, the half, negative. Double it and negate it, that gives you that, okay? So let's see, we get negative 2 times 8/3 minus 8. So I'm getting common denominator of 3. That's 8 minus 24, negative 16/3. So I got negative 2 times negative 16/3 is 32/3. And that is that area there. Okay? So what are you going to need to do if I gave you a different problem, and let's say I gave you this, whatever it is, x squared minus 5x plus 6. Probably what's the first thing you're going to need to do? What was the first thing I did? Yeah, I dropped the bars, but what did I do right after that? So I come out to the side and I look at this. What's the first thing you need to do? What do bars do? What was my explanation of the bars? Here was this without the bars, here's what it was. What's that? It takes the bars take any negative parts of the graph and flip it and make it positive. So what's the first thing you need to do? Graph this and see where it's negative. That's the first thing you need to do. And wherever it's negative, you got to flip it and make it positive. That's what you need to do. Okay? That's my explanation to you. Make sure you make a note of it. When you get bars, the first thing you need to do is graph. Look to see where the graph is negative. If you have bars, it takes any negative piece and flips it up. That's the answer. Okay? That's what you've got to do. So, another one. This is a famous graph, I'll see this one. Let's say you have this. And let's say it's from 0 to 2 pi. What's the first thing I need to do? Look at what first? Of what? Just sine of x. So the first thing I need to do is graph sine of x. Hopefully you have this memorized from 0 to 2 pi. All right, it looks like this. If not, I can send you the video on graphing trigonometric functions. So it looks like this. Now your eyes are going to what? What are your eyes looking for? Right now, because this is not my function, this is my function. So what do bars do to a function? Takes any parts that are negative and flips them where? Positive. Okay, so what's going to happen to this valley? Yeah. So right now, blue is the sine of x, but it's going to do this. The green is technically absolute value sine of x, if we look at it like that. But we don't want to integrate with bars, okay? Because I don't have a way to integrate if I have the bars there. All right. So basically, so let's do this. Right now, if I was to do this integral from 0 to 2 pi, just of sine of x, let's just do this real quick. Let's make sure we understand. If I drop the bars and I do this, what's my answer going to be? Zero. My answer is going to be 0. Why? They cancel. But we know that can't be your, this means you're going to find actual area. Why am I going to get actual area? Because everything's going to be above. My answer here to this problem is 0. It's 0 because this one and this one are identical. They cancel each other out because it's sitting down here. All right, so I need somehow, how am I going to know what the area of these two humps are? How can I get the area of these two humps? Because that's what this is. That's what we're asked to find. When you have absolute value, it takes any negative parts to do it there. So the question is, how am I going to get the area of these two humps without using bars? Because I can't use the bars and not get 0. What can I do? Just take the area of the first one, go 0 to pi. So if I drop my bars, right, and go 0 to pi, it's already above. And what do I need to do to that answer? Double it. This is why you need to understand, what does an integral give you? It gives you net area. What is this asking for? Actual area, because it takes any negative parts and flip it up. But mechanically, you cannot work with bars. So you gotta know how to manipulate your function, all right? Because now if I go 0 to pi, I get this area, and if I double it, then I'll have this other one here. And that's how I do this problem. Now let's see if you remember from yesterday, what is this area? 2. This answer is 2. 2 times 2, you get 4. So we worked this problem yesterday. So, number one, this is not something you can just water down and not something you can do halfway. You have to have a full understanding of what this symbol means and what happens when you have bars, okay? All right, so I'm always going to do what? I'm going to drop my bars and look for negative regions. And I know that bars take any negative regions and make them positive. Then I'm going to go back to the original and say, okay, well, I know that I need the area of this and the area of this, and I got to add them together. The other thing you could have done is done 0 to pi of sine x, and this is what you were saying, I think. And if I go pi to 2 pi of sine x, right, I could do this one and get that answer. That should be 2. But if I do this one as is, how's the answer going to come out? Minus, so what do I need to put here to take care of that? Yeah, so put your minus sign, and this would be minus of -2. You'd see that that comes out to be -2, and you get another 2. 2 and 2, you get 4. So what you're gonna have to do is look for any negative regions and either negate them. The way I got around it is, I would just take this area and double it, because it's gonna be the same as that. All right, so this is the graph right now of just sine. If I want absolute value of sine, that's this, it does this, just forever. You can type it in on your calculator, you can see it's just all these humps. So it's a popular type of problem you would get, okay? All right, so sample problems and absolute value, so, all right? Let's see what else. Here's a typical problem. I'll do a net area function. Wait, oh, hang on, I got one more sample to do. And then we'll pause through there for today. I'll do second fundamental theorem and the integrals of rates of change tomorrow, or Thursday. I would just break it up a little bit. All right, third example. It's going to take me a second to draw this. So 1 to 5, 1 to 5 on the x and y, and I'll give you the points. 1, 1, 2, 2, 3, 2. We're going to connect the dots. So 1, 1, 2, 2, 3, 2, 4, 5, and 5, 5. And it's just a graph that's connected like this. And that's f of x. Okay? 1, 1, 2, 2, 3, 2, 4, 5, 5, 5. I would draw this down. All right, part A. Find the integral from 1 to 5 of f of x dx. Part B. Find the average value of f of x from x is 1 to x is 5. Part C. If f of x is shifted up 2 units, find the net area of f of x up to from x is 1 to x is 5. All right, so 3 problems there. And again, the first 2 are now your understanding of integrals. What do they represent? Or the second one is a formula that we went over yesterday, right? Do you need calculus for part A? No, why not? Geometry. You see straight lines, you know that you can just use geometry, triangles and rectangles. That's what I would do, okay? So find the area under the curve from 1 to 5, right? So we box this with our green here. We're going from 1 to 5. All right, so you need to find that area. However it's easiest for you. You want to go and make that a square, make that a rectangle. There's your triangle. There's a 2 by 2. There's a square. There's that rectangle. I don't know. However you want to do it, it doesn't matter. You got to find the area under the curve. That's what this is asking for. Okay. I'll show you what I would do, and then you can do it however you want. All right, so since this is just doing stuff you already know how to do, I'm gonna go ahead and work on it here. So I would create a long rectangle here at the very bottom. And I can see that that's a 5 by 1, or sorry, 4 by 1. 1 to 5 is 4. So 4 by 1, that area is 4. There's a triangle. So there's a 1 by 1, so that area is a half. Here's a square 1 by 1, so that area is 1. Maybe I make that another rectangle there. Let's see, that's 2 by 1, so that area is 2. Okay. What else? Here, let's see. 1 by 1, 2, 3. That's 3 halves. And then this is a 1 by 1, 2, 3, so that's areas 3. All right, just add all that up. So 3, 4, 5, 6, 10, and those adds up to 2 units. I got 12 for my net area. All right. So just double check however you're doing it, make sure that you get 12. Okay. How are we going to do average value? What's the rule for average value? That's right. So I'm just going to write the formula out. It's 1 over b minus a to b of f of x dx. Well, our a and our b are 1 to 5, so it's going to be 1 over 5 minus 1. And we've already done 1 to 5 f of x dx. So since we've already found this answer to be 12, and that's a 1/4 in front, so we get 1/4 times 12, you should get 3. And remember how I defined this. This was, that 3 should give us the height of a rectangle, so think about it. If I go a height of 3 and I use the same width, that pink rectangle there should have an area identical to the area under the curve. It's a 4 by 3. See? 4 by 3 rectangle, that area is 12. So this was one of the meanings of the average value from yesterday. So that height of 3 will give us a pink rectangle with the same area under the curve. Okay? Now, last question. If f of x is shifted up 2 units, find the net area of f of x up to from 1 to 5. So what does that mean is going to happen to this graph? 2 higher. Every point moves 2 higher, so the whole picture moves 2 higher. So I'm going to try to do this with just using area again. So let's think about this. Let me erase this pink here, but that's what our average value. So Naomi, I talked about what that problem represents geometrically. All right. So we know that this object here, whatever this crazy looking here, is 12. Okay? So what I want you to do is, how can we use what we know? So this green object, right? That area is 12. Okay. What we're being asked to do is find 1 to 5 f of x plus 2 dx. Okay. That's what we're being asked to find. Now, if I move this whole thing up 2, is what I'm about to do. 6, I gotta go up to 7 at least. So I'm gonna probably put this in black so we can see what happens here. So 7, 7. These are at 2, they're now gonna be at 4. 4, 4. And this was at 1, 1, it's now gonna be at 1, 3. All right, make sure that that looks good. Now the last thing I'm gonna move is the bottom. If the bottom was all at 0, it's now gonna be at 2. So I'm gonna put the bottom here, and you'll see why in just a second. All right, so right now, if I move the whole graph up 2, there's that, okay? So my new problem is gonna be, so let me erase this. Well, just remember that this picture has an area of 12, this right here. All right, so what has happened now? What's gonna happen to our answer? If we go from 1 to 5 now, right? What's gonna happen to our net area? Exactly right. That's how I want you to picture it, what Elijah said. Because think, if we shift up, this is our old picture. See? Our old picture shifted up. So when you move up 2, you're basically placing a long rectangle in there. So once you shift it up 2, this area is still 12. So I don't have to worry, don't do all those triangles and squares again. So all you're adding is exactly right. You're adding a 2 by 4 rectangle, which has an area of what? 8. So that answer should be what? 20. That's it. That's exactly right. Now, you could also do this. You could actually just use the calculus now. Because you already know 1 to 5 of f is 12, and you can integrate 2. So the other way I could do this is I could say, okay, 1 to 5 of f of x dx plus 1 to 5 of 2 dx. This answer is 12, right? Then I can integrate 2. The integral of 2 is 2x from 1 to 5. Plug in my 5, put a minus, plug in my 1. 10 minus 2 is 8. 12 and 8 is 20. Either way, you get the same answer. Okay? But I like how you had answered this. Okay? That's how I wanted you to think of it, is with that rectangle. Okay. So we'll stop here. We've not passed the first bullet point. Net area functions, I'll do that the second 2 bullet points go together, and then the third bullet point is, or the fourth bullet point is an example problem, okay? But this is good for today. We'll stop here. All right.